Hello guys, I am back with another question, and this time you are lucky. You are gonna be a manager this time. So you are given with a task that you will be given with n meetings that are given in the form of start of I and end of I. So the meeting 1 starts at 1 and it ends at 2. So meeting 2 starts at 3 and it ends at 4, and likewise these are given. Now we are given with the task that you have to return the maximum number of meetings that can be accommodated in a single meeting room when only one meeting can be held in the meeting room at a particular time. So another point that we have to note is that the starting time of one chosen meeting can't be equal to the end time of other chosen meeting. So if one meeting starts at it ends at 5, the other meeting cannot start at 5. The other meeting that you are taking, it cannot start at 5, exactly 5, because you cannot end and start a meeting at the same time. They have to be different. So an intuitive thought says that if I want to maximize the number of meetings, then I shall take up the meetings that end first. That will help, as in I'll be able to accommodate more number of meetings, because the more earlier I end those meetings, I'll be able to take up another meeting. But if I take up a meeting that is ending at a longer span, that will be actually reducing the number of meetings that I can take in the same room.
On carefully understanding the question, we see that the more we use the in- meetings that end first, the more number of meetings we are able to inculcate in the same meeting room. Thus, we can have all the meetings that end first. Let's understand clearly by the help of this algorithm. So, firstly, we'll start by creating the meetings first. We can use a structure or maybe a class for it, and it will be having a start and ending time. You can give also uh, their IDs as well. Then we will sort them according to the ending time in increasing order, as discussed. Why initialize count variable for the number of meetings that are held. Now we will be initializing the count variable with 1, because the meeting can always be occurred. We can always have the first meeting in our meeting room, because we don't have the havoc of another meeting at the first point. Then you need to keep a track of when the meeting has ended. So we will keep a variable for it, that is previous underscore end, which will be giving the end time of the first meeting, and accordingly we will decide whether the next meeting can be held or not. So now we will traverse the rest of the meetings. If the current meeting's time, the starting time of the current meeting time, is greater than the previous end time, then only that meeting can be held. So if that meeting can be held, then we will increase our counter and we will update the previous end, because now the meeting is ending at the current meeting's ending time. Then we will return the maximum number of non-overlapping meetings, because eventually we'll land up to this. Now let's understand the algorithm with the help of an example. For better understanding and recognition of the steps, I have kept the algorithm just side of this for your ease. Let's start. So firstly, we have to create the meetings. Let's create them. We'll be giving them IDs. So let's give them IDs as well. So for the first one will be the ID, then the start, then the ending pointer, ending time. Okay, let's start. ID by 0, and the starting time and ending time respectively will be taken. Okay, so id is 0 comma start is 1 and the end is 2. Then another one 1 comma 3 to 4. Then we have 2 comma 0 to 6. Then we have 3 comma 5 comma 7. Then 4 comma, then we have 8 comma 9. Then we have 5 comma 5 comma 9. Now we are done with creating the meetings. Then what to do? Then now we have to start the meetings according to the ending time, so that we can figure out which one ends first and we can carry out it first. Let's figure out. Let's sort them. So it's 2, 4, 6, 7, 8, 9, 9. It's already sorted. No need to write it again. So now we have sorted them. We are done with making the meetings and sorting them. Now we have to count how many meetings can be held. Let's keep that counter here. And we have initialized it as 1 because the first meeting can always be held. So the previous time of it can be calculated, can be referred here from the first index itself, which says 2. Okay, so the meeting has been held. So let's start by I1 for that loop traversal on this array. So we are done with this item. Now we are here. So can we perform this meeting? We are having the previous time as 2. The previous meeting ended at 2. Now we are wanting to start a meeting at 3. Why not? We can definitely start it. So update the counter by 1 and it says now 2. Now the previous meeting end would be here 4 because the current meeting is ending at 4 now. Okay, then we proceed further. I is equal to 2. We have performed this meeting. Then we have the meeting starting from 0 to 6. Okay, is the starting time of the current meeting greater than the previous ending time? No, it's not. We cannot perform this meeting. So, no changes here. We cannot perform this meeting. Let's move further. Now this meeting says I want to be held at 5 to 7. But the last meeting ended at 4. Is the meeting room empty? Yes, it's empty. We can definitely perform it. So the count will increase to 3 and the previous ending time will be now the current time ending time, the 7. This meeting has been performed. Now we are at 4. We are wanting to hold a meeting from 8 to 9. Is that possible? The previous meeting ended at 7. Yes, you are absolutely free to carry out a meeting from 8 to 9. Let's increase the counter. Let's update the previous ending time of the current meeting. So it says 9. I is equal to 5 now. Now I want a meeting from 5 to 9. Is that possible? But hey, I am already having a meeting till 9. I cannot perform you. So the maximum number of meetings that can be held is 4. Oh, I forgot to write here, its output was also 4.
Come on, let's quickly code this up. Let's start by creating the meetings. Let's take help of the structure. So struct, let's name it meet. I'll give them ID, starting time, and the ending time. So we are having the meet structure here. Let's make an array of it. Let's define the size n is equal to start dot size. You can take either of them because start and end both have the size as same. Now we are having an empty array of meet where all the meetings can be filled. Let's fill them. For end r is equal to 0, I less than n plus. So meet of I dot id, let's give as I because each we are starting with a 0 index. Let's keep it here like that. Meet of I dot start would be equal to the start of I, then meet of I dot end is equal to the end of I. Now we have filled the meet array with all the meetings that we got as an input. Now what do we have to do next? We have to sort them according to the ending time in ascending order. Let's sort them. Meet comma meet plus n, and we have to put a comparator function because we are going to sort it according to our requirement. Then we have to define a bool function of it. Bool static because otherwise we need to create an object of this before using the function. Comparator, it will take two arguments as the two objects. Let it be a and b. What do we have to return? We have to return a dot end and less than sign because we are going to sort it according to ascending order. Then b dot end. Okay, now we have sorted the array according to ascending order of the ending time. Now we have to grab the meeting that are ending earlier. So for that we are going to take the two variables to check whether this meeting is being able to accommodate or not. Previous end is equal to, what do we have to initialize this with? We have to initialize this with the meeting or zeroth meeting, the ending time of the zeroth meeting, because the zeroth meeting will always be held because at that time we don't have any other choice. Then we have the count, and as meeting 1 has always be held, so it is 1 definitely. And now where do we start the array from? We have already done the meeting first, the zeroth meeting, so why to traverse on it again? So we have to traverse from 1. Now how do we check whether the current meeting can be accommodated or not? We have to check it by the previous end. Like if the start of the meet of I dot start is greater than the previous meeting ending time, is it? If it is, then we are definitely gonna take up this meeting. Let's take it. If we take it, the count will be increased, and we have taken the meeting now. Now what is the current ending time at which we are available to take the next meeting. So we have to update that also. So previous end would be equal to now meet of I dot end. Now what do we have to return as the answer? We have to return the count, that how many meetings we were able to accommodate. Let's return it. Come. Let's check. The given case seems correct. Let's submit this. Oh, we forgot to give a semicolon here. Let's submit it. It's correct. Now let's take a moment to analyze the time complexity and space complexity of the code that we have just wrote. So what do we let's first encounter time complexity. So what are we actually doing? We are creating an array of size n, that that would take time n. Then what we are doing, we are sorting the array. So sorting would take up n log n. Then we are traversing over the array, that would again take an n. So in all, n log n is the greater one, and actually so the total would be more overpowered by n log n, so the answer will be n log n. And for the space complexity, we are taking a meet array of size n. Then we are taking two variables, so that are not of much space, they are O of 1 only. So in total we are using O of n space.